Hello, today I want to show you some tricks how I installed the LDF4 connectors for LDF4 cable. Actually, this is an LDF air dielectric corrugated cable made by RFS. Andrew is making a little bit of a different cable, but there are a number of manufacturers that make this cable. Coaxial is another one, and right now I'm using a connector made by RFS for RFS cable. So you need to use the same manufacturer for the cable and the connector. Why? Because they design their connectors for their cables. And what tools you would need? You will need two 19mm or 3/4 inch wrenches, an X-Acto knife. You will need eyeglasses, maybe if you wear eyeglasses. You will need a drill and a stripping tool that is also sold by the same manufacturer. So when you buy connectors and cable from the same supplier, same manufacturer, you should ask for the stripping tool if you do a lot of connectors. But if you have to install only 1 or 2, 3 connectors or something like that, probably it's not economical for you to spend $200 or something like that on a stripping tool. So in that case, you just follow the manufacturer instruction sheet that comes with the connector. And you can use some hand tools like a hacksaw, you can use a knife, and you see it's very easy to follow these instructions. And so you don't need to be a super certified NASA technician, NASA astronaut or something in order to follow these instructions. But you have to do it right and follow it exactly the way they show it to you. Don't try to cut corners to make it quick, because it might cost you in impedance and service calls later down the road. Okay, so first thing, you need to straighten this end of the cable or cut a piece like I've done in here. I cut a piece according to my needs. So I need to install a cable between one connector here and one splitter there. So first I had to pre-measure. I figure out the length, then straighten up one on the end of the cable, the one I want to put the connector on. You make it straight for about 20 centimeters. The reason is that it makes the job easier for you. Otherwise, the stripping tool is going to go off center and is going to cut into the insulation, into the copper inequally, and also the stripping tool blade is going to bite into the central conductor, make it not perfectly cylindrical or round. So once you use the stripping tool, which you set the drill for the low speed, maximum 600 RPM, make sure the stripping tool is empty. Remove the debris from inside, remove the debris from sideways, and you have new blades or within 70 cuts. So don't overuse the blades. Okay, so you have good blades, clean tool, set on low speed, set on the drill mode. Don't use torque at all, because the tool will stop if the cable opposes, or if this one encounters some resistance. So the tool will stop and is going to wreck the shield, and you have to take it out, cut it again, and redo it. So you don't want to waste your time. So use on a drill mode. Strip it. You have to go by feel. So you may need to try a couple of times until you strip it that the last ring in here is cut to the middle, right on the tip. Okay, so don't cut it to the valley. So see, the edge of the cut is right on the tip, which is the middle of each groove in here, or little bumps, how you want to call these grooves in here. So it has to be right on the middle part. Then you insert the O-ring that comes with the connector. So connector kit has some grease and a rubber O-ring and the connector itself. And again, if you want to follow instructions, it's up to you. Then you use grease. After you insert the O-ring all the way to the bottom, to the last dip on the groove, you use the grease. You use plenty of grease to make sure you lubricate this O-ring. The O-ring purpose is to prevent the moisture to sneak in, to get in after the cable is being assembled. I mean, the connector is being assembled. The reason is that these cables, having the air dielectric, once they get hot or warm, they will expand the air inside. The air will get out, but once they cool down, especially during a rain or any type of temperature changes, the air will contract again, will shrink, so it will reduce the volume, and it will suck the air, including the moisture from outside. So you want this O-ring properly greased to prevent some of the moisture to get in and affect the impedance of the whole cable and the connector. So that's important. Make sure you follow the instructions that comes with the cable connector. So once you inserted this part of the cable, the bottom part of the cable, you make sure it's flush with the cut. So you should twist this part of the bottom part of the connector. You should twist it left, right, while pushing down on the cable, and make sure it stops right here. Because if you try to put some force on this part of the connector, you may slide it too much. Then you have to kind of pull it back up, and it might be difficult for you, especially if you do this one outside. So you have to take it easy here and make sure you have control on your pressure to make sure this one is not going to slide all the way down. But what I forgot to mention, before you do that, you have to make sure you cut and trim and remove all the extra plastic that might be on the cable after you strip the cable. And if you look at the cable, it's perfectly clean, and you should see all these air channels empty, hollow. You should see the way you see it right here in my recording. So that's is considered a proper clean, and is not going to affect your connector impedance right here, because the manufacturer, the engineer, designed that cable to be free of plastic debris. So once you attach this piece, it's going to look like that again, clean and flush with the edge of the shield. Then you insert the top part of the connector. And right here, it's important that when you insert this one, you do not twist this part against the cable itself. Why? Because inside of this part, there is a piece of copper, which is a silver-plated copper. It's a female part of this connector that is going to go and surround this central conductor. So it's important that you don't twist that part, because it's going to remove the silver plating, and also is going to affect the impedance of the whole assembly. Okay, so once you have that part of the connector inserted, Another important step is to use the wrenches and hold this one steady against this part, and you just turn the bottom part. So you need to make sure you don't twist this part. Again, you don't want to remove the silver plating. I have to hold the camera, but you got the idea. So you use two wrenches and you hold this one while you turn the other one. And you may have to use a custom wrench, because this wrench was not properly it's not proper size for this groove right here. I had to grind this wrench, or maybe you find different brand that is going to fit right here. But I have a couple of wrenches at the shop and they don't fit right here, so I have to use a grinder to make it a little bit thin. Again, so only this part is going to turn, so you don't turn the other one. So here is another step. As you can see, I used a lot of grease around all this O-ring. Yeah, and I should use two hands, because if I don't have a control on the force I apply here, this whole assembly is going to slide all the way down, and you don't want that, because it might be difficult for you to push it back up. This is a locking mechanism here. If I push it too many grooves down, then this locking mechanism right here, it will prevent me to slide it back up. So this part is done right. Now when you connect this pigtail or this short cable that I just made, what's important here, you don't want to put pressure. So if this one goes without any pressure in the connector itself, that means it should be alright. But if you have to pull the cable, and if you see the cable is going somewhere, like now, you see the cable, the cable will not stay properly. So you have to adjust the cable to make sure there is no pressure on the connector. So right now I still have to work on it. So one end of the cable should be loose. Why? Because it helps the cable to turn. So you don't want to turn a lot, but you need to give it some sort of a free movement to prevent the cable to twist inside of the connector, because it's important to maintain a very solid ground right here. So once you bend the cable to release to make sure you have no pressure on the connector, you can tighten it properly, and you can tighten it